and welcome. Today we're doing a question from LeetCode called word search. It is a medium. Let's get right into it. Given an m by n grid of characters board and a string word, return true if word exists in the grid. A word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same cell may not be used more than once. Example 1, we have the following board, and we're looking for word A, B, C, C, E, D. And we do see a path for that where we are not reusing any words and where we're using adjacent cells horizontally or vertically, so no diagonals. We see this, so we return true. Example 2, we want to see the word C, which we do, and so we return true here as well. And example 3, we have the following board. We want to look for A, B, C, D. We see A, B, C, but we don't see that fourth B, right? We only make it as far as 3 characters, and at this cell, we want to look for that fourth B that is either horizontally or vertically adjacent. We see the one to the left, but we've already used that getting to C, and of course we can't reuse anything, and no other combination, no other path really forms, so we output false. So we want to code up an actual word search. How do we do that? Well, like always, let's first take a look at an example. Say I have the following board, and this is the word that I am looking for. Now, in a real word search, sometimes when you're looking at the board, you can right away see the word, but if that doesn't always work, you know there is a formulaic way to actually solve real word searches, right? You want to scan through your entire board, looking for that first letter in your word. Say you find it. Well, now you want to check all around your cell for that second letter. And in a real word search, obviously you can also use diagonals, but here we want to just use horizontal or vertically neighboring cells, so just left, right, top, bottom. So in this case, for example, I see my first letter. Well, now I want to check all my sides. And if there are multiple choices for my second letter, I see that second letter present in more than one cell, I'm going to arbitrarily pick one cell and see if I can continue forming my word. Say I start from this middle cell right here, now I move on to my right. Well, I now want to perform the same search again. I want to check top, bottom, left, and right, looking for my third letter. And I can't actually reuse any of the letters that I have already been on. So I'm going to go ahead and sort of nuke these out, make them empty, just so we can keep track of what we've already seen. So we've seen the first letter, the second letter, and now I want to look for my third letter, either at the top, bottom, left, or right. And I want to see if it actually matches the letter that I'm looking for. Well, in this example, if I look on my right, it is out of bounds. If I look on top, it's not matching the letter I want. Same with bottom, and same with left. The letter does not match the one I'm looking for, and that is because we purposely changed it to make sure we can't reuse it. So if we run into this dead end, that means we actually haven't found our full word. This means that the choice we picked was wrong, right? So what we're going to do is bring this back to what it was before we picked this letter, and instead pick another one from some of our other options. So obviously we can't use the first one we started with, so that's going to stay blanked out. And now we can potentially search on the top or left. Say we go left, well now first thing I'm going to do is make sure I can't reuse it. And now I want to look for my third letter. Here I do see it. It is that B, and I have found it. So if I do find it, I return true. If I don't, I would return false. Say I hadn't actually seen it. This was also C. In which case, I would again go back, reset my board. We're pretending this is C. And go back into my first letter. Now I check on the top because that second letter is here. And say even here, I don't find whatever it is that I'm looking for. I'm looking for my B. So I'm going to reset this again. And just try to find that first letter again. So reset my board to the original and look for that first letter again, that first A. So now that I find my first A, I'm going to do the same thing, repeating that formula, now searching for my second, then my third, all the way down. If I don't find it, then I backtrack and try again in a different location. If I go through the entire board not being able to find my letter, then I return false. If at any point I do find the word, then I stop searching, exit, and return true. So that's all there is to the word search. Now let's go ahead and code it up and then use our code to actually perform a word search. All right, the first thing that I want to do is look for that first letter in my board. So for that, I'm going to iterate through my entire board. And I want to go through all my rows and columns. So how many rows and columns are in the board? So rows and columns are length of board and length of board at index 0. So that first row, how many columns does it have? And I'm going to be looping through. So for row in range rows, in the range of the number of rows I have, and same with column for column in range columns. I want to check every single cell. So board of row column, so whatever index I am on, we start off with 0, 0, so that first cell. If this equals that first character in my word, so word of index 0, so if these are equal, then I want to check for the remaining letters. So we want to go down, and it's called a depth first search. So we want to go all the way down looking for our remaining words, and I'm actually going to make a helper function to do this. So I'm going to call this DFS. And what is this going to take in? I want to pass in my board because we're going to be changing our board based on how many letters we found. I want to pass in what my word is, what index I'm on in the cell, so my row and column, and finally what index of the word I'm looking for, so index. How this helper function is going to work, we're going to be calling this over and over, searching top, bottom, left, right, and each time we're going to be passing in an incremented index number. So we're always going to be looking for that next letter. And we're going to be making 4 checks, so, row plus 1, row minus 1, column plus 1, column minus 1. And as soon as we find the word, we're going to be returning true. So if we do return true, so if self.dfs of board, word, row, column, and that first index we start with is 0. So if this is true, then I return true. And these are 2 if conditions. We can sort of merge these together. So if I find that first letter and I find my entire word, so in the end of this entire depth first search, we return true, I will return true, I have found my word. If not, I continue going back into my for loop. If I have made it all the way out of my for loop, still have not returned true, that means I never found the word, and we are going to return false. Okay, so now how do I want to write up my helper function? Again, what does this do, right? This is a depth first search, and we're going to perform this recursively. We're passing in a board, what our word is, what row and column we're on, so what index of the board, and index for word, so what character are we looking for. So how we're going to do this is we're going to take our row and column, whatever's being passed in, we're going to see if it matches whatever index we are on for the word. So does our current cell match the letter we're looking for? If it does, then we're going to make 4 more checks. We're going to call this function 4 more times in the different locations looking for index plus 1, looking for that next letter. If we find it, then we're going to make an additional 4 checks, and we're going to keep recursively calling this function until we return either true or false. So this is a recursive function, which means we need 2 things, the base case and the recursive case. What are our base cases? So there are going to be 2 base cases here. Either we return true or we return false. If we return true, that means we have found the word. So how do we know if we've actually found the word? Well, if the index that we are passing in is greater than the length of the word, that means we found all the letters that we needed to so far. So if index is greater than equal to the length of the word, then we return true. That means we have found our word. Now, when do we return false? If the letter we are on doesn't match the one that we're looking for, or if we're out of bounds. So if row is greater than equal to length of the board, or row is less than 0, or column is greater than equal to length of board of 0, or column is less than 0, or the cell doesn't match the character we're looking for, so board of row and column is not equal to word at index whatever we are passing in, then we return false. What happens if we don't go into any of these if conditions? That means the cell we're on matches the letter we're looking for. So what do we want to do now? What we want to do now is actually nuke out that cell, right? We want to get rid of it so we don't reuse it. But we can't just empty it out, because say we don't find the word going down this path, we actually want to undo getting rid of that letter. So what we want to do is save it. So I'm going to save my letter, so board of row and column. I'm going to save it before I get rid of it. So now I've saved it, I can go ahead and get rid of it. So board, row, column, and I can set this to anything. I'm just going to set it to empty string. So now that I have emptied it out, now I want to make my 4 searches. So I am going to call self.dfs on board that I have now modified, right? I have emptied out the cell that I was just on, passing in that same word. Now I want to change up the cells that I'm searching for. So I search for whatever cell is above me, so row -1 and column, and I'm going to pass in index +1. Or if I don't return true here, maybe I return true from the cell below me, so self.dfs on board, word, row +1, column, index +1. Or maybe it's on the left and right of me, so self.dfs on board, word, row, column, +1, index +1. Or that last final choice, self.dfs, board, word, column -1, and index +1. So this is going to return either true or false, and I'm going to save that variable in found. So found is going to store whether or not we've returned true or false from all of these searches. And the reason for that is because in the end, I want to return found. And why can't I just return right away, right? Why do I need to store it in found and then return whether or not we've found the word? It's because I actually want to change up my board. So once I've gone through all of these conditions, I want to reset. Say this returned false, right? I want to reset my board. So what I'm going to do is have board of row column equal that letter that I had saved. If I had returned this answer, I would have ended my function, because anytime we have a return, we exit our function. So instead, what we're doing is we're just saving in a variable, returning that variable later on, because we want to reset our board. Say we went down multiple recursive calls and we didn't find our word. Well, now we want to go back to the board as it was. And we saw in this example, right? If we didn't find it, we would put it back to the letters that they were and continue searching. So this is sort of just making sure that we don't erase it. We still hold on to that data. And in the end, we just return true or false that goes into our original function. So let's go ahead and run this code. Runtime error. Let's see, missing argument. We did not include row here. There we go. Okay, now if we run the code, it's accepted, and we can go ahead and submit this. Okay, and it is accepted as well. So talking about space and time complexity. For space, we are going through a recursive call, right? So it's our call stack that's taking up space here. And we would recurse as many times as there are characters in our entire word. So if we had k letters in our word, our space would be O of k. Now, what about time? Time is a little bit similar, but how do we think about this, right? We are going through, iterating through an entire board. So to begin, that is at least O of m times n. So we're going through every single grid. Now, at any single grid, what are the max number of calls that we could be making? Well, what are we doing when we're searching for our word, right? We're looking for every single character. So say, for example, I have a board that looks like this, right? A bunch of A's, then a D. What are we doing in this scenario? I start off with index 0, 0. I find my first letter. Now I want to look for my second. I'm going to look top, bottom, left to right. Obviously, these two are out of range, but those checks sort of do happen, right? They just go out of bounds, but we do call them. So those don't really amount to anything. Now I check right. Say I go to my right first. Well, now I'm looking for my third character. I've gone through these two. I don't see it, so I backtrack. I go try this option. I don't see it. Now I backtrack all the way. I don't even use this index 0, 0 as my first character. I move on. Try to do this as my first character and make the same checks, top, bottom, left, right. And I do this all the way through. So for any character, I'm going to be making 4 checks. And I'm going to be doing this for as many letters that I have in my word. So for that first letter, it would be 4 checks. The second letter, it would be another 4 checks. The third letter, it would be another 4 checks. And when are these checks happening, right? So if I'm starting off my first letter, I make my 4 checks, and I continue down. I didn't see it, so I stop. Now I go to my next letter and do the same thing again, make the same number of checks, the 4 checks, then the 4 checks, then the 4 checks again. So yes, I'm iterating through, but what is this being multiplied by? This is being multiplied by the 4 checks for every single character that I have. If I have 3 characters, that's 4 times 4 times 4. So it's 4 to the power of k, if k is the number of letters that I have in my word. So the time complexity for this is O of m times n times 4 to the k. It is not the fastest problem, but this is what the time complexity is. And for this reason, we probably shouldn't be going through an entire example like we usually do, but we are going to be going through an example just so we can see how our code is running line by line. Okay, we're going to be using this example to go through and test out. So with this example, this is my board, and this is the word that I want to find. Going line by line, we start off from the top. We find out what our rows and columns are. So rows, columns, they are both 3 and 3. This grid has 3 of each. And now we're looping through. So 4 row in range of rows, 4 column in range of columns. Row and column right now begin with 0, 0. Now we make our first check. Is the cell we're on equal to the 0th index of our word? The 0th index of our word is A. And does A equal the value at this index of the board, 0, 0? They're not equal, so we're out of this for loop and back in. Now column equals 1. So now we check this cell. Is it equal to the first character of our word? It is. So now we call DFS. So we call solve.dfs with our board. So we're going to be passing this whole board in. And let me rewrite this. So we have board. We are passing in our word AAB. The row and column that we are on, so that is 0 for row, 1 for column, and 0 for the index, right? That's what this DFS function takes in. So now we want to call DFS with the following inputs. What do? The first check we make is index greater than the length of the word? So the index we're on is 0, and let me just write these out so we know exactly what is which. So word is this, word is this, row, column, index. These are the values that we've passed in. Index is 0, length of word AAB, that is 3. That is not true, so we do not go into this if statement. Now we're in this if statement. If the row or column, are they out of bounds? 0, 1, they're not out of bounds. Or if the cell we're on doesn't equal the index that we want, so the cell we're on is A, does it equal the index of the word? So index right now is 0. Word of index 0 is A. They are equal, so we don't go into this if condition and we don't return false. So what do we do now? Now we save letter. So board of row and column. So at 0, 1, the board holds A. So we're gonna save that letter. And now what do we do to our board? We wipe out that character. So say this was the board that we had. This is the board that we've input, right? To visualize this, this is what we're doing. We are wiping it out. And now we are making 4 checks. So now we're calling found with the following inputs. So we're calling self.dfs with this board. So we're calling with this board. We are passing in AAB. What else are we passing in? Row -1, column and index +1. Okay, so row -1. What row are we in right now? 0. So we're passing in -1, the same column, and index +1, which is 1. Or what is the second call that we are making? Let's copy paste these in actually. So for board, we are passing in the same board and the same word. This time we're doing row +1. So we started off at 0. So 0 + 1 is 1. Column stays 1. Index +1. So that is 0 + 1, which is just 1. Or we call it again. And I'm going to copy paste these in. With row staying as is, column -1. So that's 0. Or row staying is as is again, and column +1. So these are the 4 calls that we make. But before we can actually get to all of them, we read left to right, right? So the first thing that we come across is this DFS. So now we are recursively building out our call stack. This is our new call stack. So here again, let's say board is this, word is this, row, column, and index. So we're going to be doing the same checks again. We are back into this if condition, right? We check, is the index greater than the length of the word? It is not, we cannot return true. Now we make the following checks. Are we out of bounds, or does the cell we are on not equal to our index? So our board right now looks like this. And we are on row -1, column 1. We are out of bounds, right? Row is less than 0, so we are going to be returning false. So this call returns false. So for this call, we have false. And now we want to do the same thing for all of these calls going down. So for all of these, we will be making the same calls. Now looking at the board, we know that we will actually not be able to find our word A, B from this starting index. So we know these will all return false, right? These will all return false. We could go ahead and go through all of them, but just to save some time, this will all be false. So found is false. We are back into our original caller. We have popped back up. Now, what do we do once we return from here? Now we want to bring back the board to what it was. So board at row column equals letter. So we're putting A back into the board, and we are returning found. We're returning false back to this caller. And now that this has returned false, so we're going to be going back into this for loop. So we were at 0, 1. Now we are at 0, 2. So at this index, doing the same things over and over again until we finally hit this condition. And we would, once we start here at this A, go left and then down. At B, we would be making some more calls. So we wouldn't be making all of these calls. But at this point, we would see that our index is greater than the word after we hit B and after B tries to make calls. So we would finally return true. Up until then, we would keep returning false. And if we do have an example where we can't find the word at all, we would be looping through, going through all of it, in the end, returning false. So this is how to do a word search. If you have any questions at all, let me know down below. Otherwise, I will see you next time.